Alright, welcome back class. I hope you all had a great weekend and you also managed to do your homework. It's really important when learning a programming language like Python or SQL or statistics in general, machine learning, that you do it consistently so that we continue to build, and when we get to the end of this course, you're going to be towards your path as a data scientist or wherever you want to go. So, we'll have time at the end of class to actually look at some specific homework problems, but for now we're going to do a recap on some key concepts, and let's kick right off. Correlation. Who can tell me what correlation is? How about, okay, John, why don't you tell us about it? Yeah, great. Yeah, it's in a way a measure of a relationship between two variables. And why does this matter? When we're looking at two data types, or for instance, chocolate sales and gasoline, you might want to know if there's some kind of relationship. Perhaps you're a business that is trying to forecast chocolate sales, or maybe you're just an econometrist that is looking to do your PhD. Whatever it is, sometimes you want to know relationships. Now, however, looking at chocolate and gasoline sales, if we saw a rise in chocolate sales in Australia, for instance, and in Australia at that same time saw a raise in gasoline prices, would we expect that there's some causation here? No. Chocolate sales most likely aren't influencing or causing gasoline prices to increase, which is our difference between correlation and what we saw last week, causation. Also, very important is that we look into the central limit theorem again. Now, who would be our brave volunteer to tell us what this is? All right, Ashley, excellent. Okay. Yeah. Excellent. So with the central limit theorem, like you said, beautiful recap, is that rather than grab data for an entire population, what the central limit theorem gives us, if we take a random independent sample of that population, what we'll tend to see is that all these samples will tend towards the mean of that population, which basically tells us that we can take a sample and not have to go do a study of the entire population, which isn't cost effective. We will see that this is really important for regression and other statistical techniques. So going from here, this is why it's important. It is a foundation for what we'll see in regression and many other things that we'll see. All right, let's move forward. So, in the scope of this class, it's focused on regression, but we need to build up to it, and we're going to go beyond it. So first, what is regression? Simply put, it's a statistical technique to look at the relationship between two variables with a linear method. Usually it'll be x to y, as you've seen your entire life. We'll begin with the mean, because this serves as a baseline so that we can know if our regression model is actually doing better. Otherwise, why are we doing it? When we're looking at regression models in this course today, we're going to focus on linear models with one variable, which is sometimes known as simple linear regression, or multivariate linear regression. Now, with anything, there are assumptions that must be withheld. With regression, there are 4 assumptions, and we'll go into depth on these. Why is this important? It's important because you might build a beautiful model where your measure of accuracy, your R-squared, is great, 95%. However, if the key assumptions aren't held, then it might be a falsely good prediction accuracy level. Lastly, we'll look at some examples and applications. So, first let's start off with some key terminology, some bricks as we build up our foundation. Residuals. You'll hear this a lot. What it is when you make a prediction on, say, historical data, the residual is the difference between the actual value and your predicted value that you used to build the model. So when you see a line and points above it, it's that vertical distance. We already talked about sample and population, but it's important to reiterate it. We're focused on a representative sample that is unbiased, which is maybe only 50 observations rather than the whole population that it represents. Who can tell me about independent and dependent variables and what they are? Craig. All right. Yes. What we're trying to predict is the dependent variable. This is also known as the response variable and also sometimes called the predicted variable, as opposed to the independent variable, which can also go by the predictors. All right, let's keep on going forward. Lastly, regression. We mentioned it again, and quickly, it's a statistical technique that is measuring the relationship in a linear method between two variables, or one variable and two or more. All right, so I know you all love data science, and that's why you're here, but we also want to do something great in the world and make money and have influence, maybe just learn to learn. However, in business, we want to know, why in business do we want to predict future events? Let's get some examples. Okay, maybe you could predict the lottery. Excellent. Predict future stock prices. All right. Another good example. Let me give you a practical example when it comes to energy. In natural gas, which I worked in previously, we would buy gas for the day that was coming and also the month that was coming. What we wanted to do was to be able to predict how much we needed, because if we were wrong, there were penalties. But also the cost of gas would be more if we bought too much, or if we bought too little, we'd have to buy at a higher price. So in that way, it was really important for us to actually be able to know what our customers would use. You can also run into this to predict how an epidemic will spread. How quickly is that going to go from 10% of the population to 20%? Or if you want to predict a patient's potential for cancer. These are all applications that regression is used in, perhaps not linear or multivariate, but they can be applied there as well. So, we're going to start off with a scenario, an example that will illustrate all the key points that we want to see. We're in a shoe store. Yes, even there you can apply data science techniques. So we're in a shoe store, and what we want to do, our goal, you as a data scientist, wants to be able to predict the shoe size of a customer. Now, if you only had all the shoe sizes that you've sold in the last week and no other data, what do you think the clerk could use from that data so that when he goes back to the stock room, he grabs a shoe that will probably work for his customer? One caveat. Let's say he has not asked the customer what their shoe size is. Yes, we could use potentially the last shoe size that was bought by a customer, or other statistical measures such as the mode, which is the most ordered shoe, or perhaps the median. But what we'd like here is the mean, or the average, which is a model that actually will show, of these scenarios, the least error, and is a simple model that we can use as our baseline for shoe prediction. So when we look at this data, the store clerk could go look at the average and go grab that shoe. And more often than not, this is his best model from this. However, what if we had additional data? What if we also, in our CRM system, a customer relationship management system, we had other information such as their age, their ethnicity, their weight. This could possibly be used as independent variables to predict our dependent variable on their shoe size. So let's get into Python and look at this. Okay. So right now we're in Spider, which is an IDE, so that we can use Python engine. And the first thing that we want to do, first of all, this right here allows us to put comments that will stay in our code. And the first thing we're always doing is importing the modules. We're importing the pandas module, the matplotlib, numpy, skylearn. And what this will allow us to be used as our tools so that we can start to build our model. We have imported those modules. Let's move on. So in this case, like we saw about 2 weeks ago, is that we're going to be importing data into pandas. This data is in a CSV, or a comma separated value format, which is very common, not just comma, common, so that we can read in the data. This annotation of header lets us know that there are names on the top of these columns. So let's import this data, and we're also going to describe it. Now if you look, you can see from the description that we have 40 counts, or 40 observations, in 2 columns, age and